let's start.
Will you also be clearing the doubts?
Yeah, we'll be taking it at the end of the session. So let me share my screen.
Sir, we will be doing questions or you will explain concepts first?
Through questions, we can take concepts also through the questions. So is my screen visible?
Okay.
Yes, sir, visible.
Okay, so let's start. Okay, so there's no peer deck. You don't need to go to join PD and type something because that feature is not working. So I want you to solve it and keep the answer with yourself. And after that, a certain time, we will discuss each question. So you just need to ignore this part. So yeah, this is your first question. So I'll give you maybe 2 or 3 minutes to solve this question. Okay, so do you need more time or should we discuss this question?
Sir, discuss the book.
Okay, so it says an urn contains 5 blue balls and 8 red balls. A ball is chosen at random. What is the probability that the ball is blue? So, so one ball is chosen and we need that probability that the ball is blue, right? So how will you do it? So there are 5 blue balls, 8 red balls. So there are 13 total balls in the box, right? So out of this, I only want a blue ball. So how will you choose one blue ball from 5? 5C1. That will be a favorable case. And the total number of cases will be how much? One ball from the total, that is 13C1. So 5C1 is 5, 13C1 is 13. So 5 by 13, which is 0.38. So is there any doubt?
No, sir.
Okay, should we proceed? Okay, so this is your next question. I'll give you 3 minutes to solve this.
Hello.
Yeah, tell me.
Okay.
This is the second question. So attempt this question. Sorry, you are not audible. Can you repeat? Okay, so do you need more time or should we discuss this question?
Discuss.
Okay. So it says an urn contains 5 blue balls and 8 red balls. 2 balls are drawn at random without replacement. So what is the probability that the first ball is red and the second ball is blue? Okay, so can you see my board right now?
No.
Okay, no, right. Okay, can you see it now?
Yes.
Yes, sir.
Yes.
Okay. Yeah. So it says that there's a urn, and in that urn there are 5 blue balls and 8 red balls, and probability that first ball is red and second ball is blue. So this is a question from conditional probability, right? So first, what will be the probability that the first ball is red? How many red balls are there? 8, right? So it's 8C1, one red ball I'll pick up out of the 8. And what is the total number of balls now? 8 plus 5, 13C1, right? So this is drawing first ball. Now in the question it says without replacement. It means whatever ball that we are drawing, we are not keeping it again in the box. So now what is the total number of balls? 12, right? Yeah. Now I need the second ball to be blue. So how many blue balls are there? 5. So out of this, I want 1. Now the total number of ball is 12. So 12C1. So it will be 8 by 13 into 5 by 12. So if you do this, you will get how much? 40 upon 12 times 13 will be 156. And if you divide this, you will get 0.26. Is this correct? Did you get this?
Yes, sir.
0.26. Yeah. So if you write
Can
it
we
in terms of, yeah, sorry.
can we do previous question by combination?
Sorry, you want the previous?
Can we do previous question by the method of combination?
Combination. Yeah, you just see in the previous question, it said that 5 blue balls and 8 red balls, and you want, so you're drawing one ball and you want the ball to be blue. So there are how many blue balls? 5 blue balls, right? So you pick up one 5
Yes.
ball, one 5,
5C1.
mean, yeah.
5C1
So this
upon
is picking 13C1, right?
13C1.
So yeah, it
Yes.
will be 5 upon 13. Yeah.
Yes.
So if
Thank
you
you.
write it in terms of the, yeah. So this, so you can do in another style as well. So let's suppose I'm defining events. Let's say R is first ball is red. This is one event. And let's say B is second ball is blue. This is another approach that you can do. So the question says that the first ball is red and the second ball is blue. So it means first is red and second is blue, right? So this is first event and this is second event. So you can write like this: probability of the first event, that is first ball is red, times probability of the second event B, given that I have already drawn the first ball. So this is first ball is already drawn. So this is conditional probability, right? So I have already drawn the red ball. Given that I have drawn the red ball, what is the probability that the second ball is blue? So what will be this? It will be same 8 by 13, drawing the first red ball, and now I have 12, and out of this, how many are blue? 5. So you will get again the same answer. So this is another method of doing this question. Okay.
Okay.
Yeah. So let's go to the next question. Okay, so yeah, this is the solution for this. 0.26 is the correct
Given
answer.
with replacement, can we directly divide by 13C2?
No, actually, in the question it says the first ball has to be red and the second ball is blue. So the order will matter here. Yeah, and the balls are drawn without replacement, right?
Yes, yes.
So first ball has to be blue, then the second ball is blue. So if you take
It has
two
to be
balls
divided by only
together,
13C1.
no, if you do see if in one row, if you take out two balls, we don't know the order, right? In that case, the order will not matter, right? But the question says first ball has to be red and the second ball has to be. So that's why we are drawing first one, then we are going for the second.
Yes.
Okay, so 0.26 is the correct answer. So yeah, try this question. Syllabus for quiz 2 will be from week 1 to 8. More weightage will be given for week 5, 6, 7, and 8. So majority of the questions will be from week 5 to 8. And there will be some questions from week 1 to 4. Do you need more time? If any one of you are solving, you need more time, or should we discuss?
We can discuss it.
Okay, we should discuss then. Okay. Okay, so 0.89, 0.89. Okay. So, okay, let me open my notebook. Wait. Okay, so can you see this note, writing pad? I mean, question in the screen.
Yes, visible.
Yes,
Okay.
sir.
Okay, so in this question, it says that in a population, 45% are female and 55% are male. Among all the females, that is among those 45%, 9% are left-handed. And among all the males, 11% are left-handed. Okay, person is randomly chosen from the population. What is the probability that the person is not left-handed? Okay, so okay, let's define some events. Let's say I'm defining an event M, which is let's say selected person, because we need to select a person from the population. So let's say selected person is male. So this is an event M I have defined. And let's say this is another event, which is I am defining as selected person is female. So another event is L. Let's say this is selected person is left-handed. Is left-handed. So in the question, what is asked is the person is not left-handed, right? So can I say the question is asking this P of L complement,
Yes.
right? So can I write like this? P of L complement is 1 minus P of L. If I find
Yes,
all
sir.
the person who is left-handed, and if we subtract 1 from that, so I'll get person who is not left-handed, right? Okay,
Yes.
so now in the question, there are a few data that is given to us. So let's write those data. So first thing that is given to us is 45% are female. So what is the probability that they're female? It will be 0.45, right? And the probability of being male is 55%. So it will be 0.55, right? Now it says 9% females are left-handed, 9% are left-handed, and 11% left-handed are male. So what is this? How can I write it in terms of mathematical expression? Can I write it like this? Given it is a male and it is left-handed, left-handed male is 0.11, and given the person is female and it is left-handed is given out to be 0.09. Can I write like this? See the question. Given that the person is female, 9% is left-handed female. Given the person is male, 11% is left-handed. Can I write it like this?
Yes. Sir.
Yeah. So now what we will do is we will find first. Okay. So we want P of L, right? This one we need to find. So what is P of L? That is person who is left-handed. So can I write like this? So left-handed person can be either male or it can be either female, right?
Yes, sir.
So can I write? Yeah. So can I write it like this? Out of the male, I'm taking all those left-handers, and out of the females, I'm taking all the left-handers. This will give me all the left-handers of both the genders. Is there any doubt in this expression? From all the males, I'm picking up all the left-handers, and out of the female, I'm picking up all the left-handers. And if I add it, I'll get all the left-handers in the population. Is
Yes.
there any doubt in this line?
Sir, if we
No,
add 9% and 11%, then it is also the left-handed person.
Uh, okay, you're saying if I add these two,
Yes, sir. Yes.
but it is conditional probability, right? It is conditional, right? So So did you understand this line?
Yes, sir.
Okay. Now, okay, so can I write like this intersection L? So do you know this, right? P A given B can be written as P A intersection B upon P of B. This is conditional probability, right? So
sir.
from here, can I condition it in? Let's say I'm conditioning it at mean. So can I write L given M times P of M? Can I write it like this? This expression can be written as P of L intersection M upon P of M times P of M. So it will get cancelled. I'll get the same expression. Why am I doing this? Because this is given to us and this is also
Sir,
given to us. So I can calculate this. Yeah.
can you please explain this part?
This one, right?
Yes, sir.
So what I am doing, see, in the question it is given to us, given that the person is a male and he is left-handed, is given to us, right? So I'm using this expression. So let's write this one. Given to us, right? This is given to us, right? 0.11. So now this is conditional, right? So how to write the conditional? What is the formula? L intersection M upon P of M, right?
Yes, sir.
Now this is 0.11. From here, can I calculate M intersection L, which will be 0.11 times P of M? Now P of M is given to us, right? So what is P of M? 0.55. So 0.11, this is given to us 0.55. So from here, I got P of M intersection L. Is there any doubt?
No, sir.
Okay. Now, similarly, what I will do is I'll calculate P of F intersection L. This one I need to calculate. So for this, there is given that given it is female, which is left-handed is given to us 0.09. So same thing I can apply here. L intersection F upon P of F equal to 0.09. So from here, I'll get L intersection F equal to 0.09 times P of F. Now P of F is given to us, right? 0.45. So it is 0.45. So this we know, and this also we know, right? So from here, can I write P of L, which was M intersection L plus P of F intersection L. So it will be how much? 0.1 times 0.55 plus 0.09 plus point into 0.45. So how much will it come? It will be how much? 0.0605. 0.09 times 0.45 will give you 0.0405. So if you add them, you'll get 0.101. Now we want the
Yes, sir.
complement of this, right? So L complement will be how much? 1 minus P of L. I'm removing all the left-handers. So 1 minus
0.899.
0.101. 0.899. So how many of you got this correct?
Yes, sir.
Okay,
Yes,
is there
sir.
any doubt?
Can it be solved with the contingency table?
Sorry. Sorry.
Sir, can you show the
Can
question
we
once?
solve with contingency table? Can we use
Contingency
that?
table. Okay, how will you solve it using contingency? Okay, any one of you solve it
Sir,
using
can you show
contingency
the
table?
question first?
Yeah,
No,
so
sir.
this is
It can.
the question. This is the question, right? Okay, so should we move ahead? How many of you got this correct?
Yes, sir. Got correct.
Okay.
Sir,
Uh,
could you please
yeah.
scroll down?
Sorry.
Please
Scroll down.
Okay, can you repeat?
Scroll down. I want to see the answer.
Okay, scroll down. Okay, yeah. Yeah, this is the solution.
It is just a left hand. Right? They're asking for the right hand.
Can you repeat? Your voice is breaking.
They're asking for not a left hand, right?
Yeah, we are asking for the probability that the person is not left-handed. So first we are finding the people who are left-handed and we are removing all from the total.
Oh.
Sir, can you just explain conditional probability once?
Okay, we'll do that. Okay, we'll do that. Okay, so did you get this?
Got it.
Sir, this intersection, how you got? I'm confused.
So conditional is like this, right? Let's say I'm
From
conditioning on
conditional
B.
from probability.
So how will you do this? A intersection B given probability of B, right? If A
Yes,
and
sir.
B are independent, then in that case, P of A intersection B will be, how can we write it? P of A times P of B, right? So in that case,
Yes.
A given B will be P of A, P of B upon P of B. So it means P of A given B will be P of A. So what do you mean by this? A is independent of B. It means the event A that is occurring is not dependent on B. So whatever B happens, we are not caring about it. We're just focusing on this event. So it means given that B has already occurred, what is the probability of A? So B has already occurred. Like that the case of the second question we did, right? So first we draw the ball, red ball. Now we are not concerned about whatever the second outcome is. So first ball is gone. Now the second ball we want B. So the first event has already occurred, right?
Yes, sir.
Yeah. Okay, so there are many questions. We'll take it. Yeah.
Sir, so in this case, A is left-handed, B is it is a male.
Sorry, can you repeat?
Sir, in this question, we
Hmm.
did not F P of M intersection L.
Yeah.
So, sir, first event is it is a male, and second event is it is a left-handed.
Yeah. We are taking all the male left-handers. M intersection
Okay.
L denotes all the left-handers who are male. This is what it means.
Yes, sir. Okay.
Yeah. So let's go to the next question. So this is the solution. We just did it. Okay, this is the next question. Okay, so how many of you did this question, or do you need more time?
Excuse me, sir.
Yeah, go ahead.
Sir, can you tell the code for the joint PD? I actually
So
joined late.
okay, yeah. There is no code. You just need to solve the question, and then we will discuss. There's some issue with the peer deck, so there's no need to join that website joinpd.com. So you just solve the question, and then we are going to discuss it at the end of this time frame. Okay.
Okay, sir. Okay, sir. Sure. Sir.
Okay. So should we discuss this question?
Yes, sir, you can.
Okay.
Yeah.
Okay. Sure. Okay. So it says the student writes an exam with two sections. Probability of passing section 1 is 0.8 and probability of passing section 2 is 0.9. What is the probability that he passes both the sections? Okay, let's define two events. First is, let's say, event 1, which is pass section 1. And let's define another event, event 2, which is passing section 2. Okay. So we need the probability that he passes both the sections. So it means he has to pass event 1, that is, he has to pass section this 1, and he has to pass section 2, which is event number 2. Now, these two events are independent. That was the trick, actually. So if the probability of passing section 1 and the probability are two different things. So passing section 1 is independent of passing section 2. How many of you got this? So is there any doubt? It is independent. So what we can do is probability of event 1 times probability of event 2. So what is the probability of event 1? It is 0.8, and the probability of event 2 is 0.9. So it is 0.72. How many of you got this correct?
Sir, I got it correct.
Yeah. So basically these two events are completely independent. They're not dependent on each other. So passing in section 1 and passing in section 2 are not dependent on each other. So if it is independent, then we can use this formula, right? So A intersection B, if A and B are independent, then we can write P of A times P of B. So this is the trick that you need to use in this question. Okay, so let's go to the next question.
Roll up for a minute, just a moment.
Yeah.
Sir, if the question was, what is the probability that he will fail, then how would you solve it?
Probability you would fail.
Both the sections.
Fail in both the sections.
Yeah.
Then you will take 1 minus of this, right? 0.8 will become 0.2. 0.9 will be 0.1. 1
Okay.
minus of it, right?
Yeah.
Then you will multiply. Yeah.
So
Sir,
0.2
how we
into
know such the
0.1.
question?
So 0.2 into
Uh,
0.1 will become 0.2, right?
See, failing depends, right? Which section you have to define the problem, right? Failing in which section? It is in section 1 or in section 2, right?
Both.
Which section?
Both.
Both, then it will be independent, right? Then in that case, you can multiply 0.2 into 0.1.
Yeah, so it becomes 0.2.
Yeah, 0.2 into 0.2. So it will be 0.02, right? I think.
Yeah. Sorry.
Yeah. Okay, let's go to the next question. So,
Sir, how to identify the question is of independent event?
okay, so it will be in the language of the question itself. You can recognize. Okay, let me show you. Wait. So in this question, actually, this one was the question. The hint was the events of passing section 1 into independent. Okay, I did not show you this slide. So yeah, it will be mentioned in the question, or from the language also you can understand the events are independent or not. Yeah. Okay. So try this question. Okay, we solved it. Yeah, try this one.
Sir, for the previous questions, how would we have to solve the events are independent?
Sorry.
The
If
previous
they are dependent, then you have to use conditional probability.
Okay, sir. It be even intersection E2 divided by the particular event.
Okay, we will take that question as well. Okay, if they are dependent, then what will happen?
Sir, discuss the question.
Okay, sure, we can do that. Okay, so what is the answer that you got? What is the value of P? Anyone? solve this?
0.571.
Okay, tell me in fraction. What did you get?
4/7.
4/7. Okay. Anyone else?
4/7.
4/3.
4/3. 4/3. 4/3, how it will be? It is probability, right? Probability can be greater than 1. 4/3, how it will be? Okay, so let's check this question. So it says a student appear for an aptitude test of a company that has a total of 3 sections, and student will pass the aptitude test if he passes in either section 1 and 2 or section 1 and 3. Now, probabilities of the student passing section 1, 2, and 3 are given. P 1/4 and 1/3 respectively, and also these are independent events. Okay. So the probability of passing the aptitude test is given to you, and you need to find the value of P. Okay. Let's define some events. So what we need is let's define an event called pass. What it means, if the student passes in section 1, so pass in section 1 and pass in section 2, or so how will he pass, right? He will pass if he passes in section 1 and section 2, or if he passes in section 1, so section 1 pass and section 3 pass, right? This is given in the question. So if any of this happens, the student will pass. Is this clear?
Yes, sir.
Is there any doubt in this till now? I'm just defining the event pass. So how will he pass? Either he will pass in this or he will pass in this. So if I take this to be A and this to be B, so what will be P of pass? It will be P of A. What is OR? OR is union B, right?
Yes, sir. Union.
So if I expand this, it will be what? P of A, P of B minus P of A intersection B, right? Is there any doubt? I'm just
Yes, sir.
writing the formula of P of, yeah. So now what is P of A? So it is, he will pass in section 1, that is section 1 pass, and section 2 he will pass. This is A. Plus probability of B means what? He will pass in section 1 and he will pass in section 3. What will be A intersection B? It will be section 1 pass and section 2 pass and section 3 pass, right? Are you getting this step? A intersection B is basically what? Intersection of this whole thing. So it will be section 1, 2, and 3 together taken, right? Section 1 he will pass, section 2 also he will pass, and section 3 he will pass. Now probability of section 1 pass and section 2 pass is given to you. How much it is? Now since it is independent events, so what can I write? Section 1 and section 2.
A
See,
into
individual
PB.
probabilities are given to you. Yeah, P into 1/4, right? Because it is independent. P into 1/4. Because independent event. All the 3 events are independent. Next, section 1 and section 3. Probabilities are given to you. Section 1 is P, section 3 is 1/3. So it will be P times 1/3. Now it will be section 1 pass, section 2, and section 3. So it will be P into 1/4 times 1/3. Now this is given in the question. Probability of pass is given to you, right? How much it is? 1/3. So this is the equation that you need to solve. So from here, if you solve, how much will you get? So 1/3, this is P/4. This is P/3. This is P/12. So if I multiply by 12 both sides, so I'll get 1/3 times 12, P/4 times 12, P by 3 times 12, P by 12 times 12. So it will give me 4. This will be 3P. This will be 4P minus P. It will be 4, 6P. So P will be 4 by 6. If you simplify it, it will be 2 by 3. So this is the value of P. How many of you got this? Yeah. Is there any doubt?
Sir, I have
So
one
could you
doubt.
just show the question once?
Yeah. See, the events are independent, right? So that's why we can write P of A intersection B as P of A into P of B.
Sir, I have a doubt.
Yeah.
How to approach probability question?
The approach is first you write down the events like I wrote, right? Past is an event that I've defined. So this is an event. So what is this event? The event is the student is passing in section 1 and section 2 is 1, and section 1 pass and section 3 pass is another. So it is given in the question. So whatever information is given to you, we just write down those things as like this. Then you try to find out the probability.
Okay.
Okay. Yeah. So the value of P will be 2 by 3.
Sir, why are we finding P of A intersection B intersection C?
This is the formula, right? So if you
Sir,
see, if you write this, yeah.
Sir,
So
if
P
So
of
is it
A,
because it is given section 1
sorry.
and 2 or section 1 and 3, we have to use the union formula?
Yeah, or is union, right? So that's what I did. So A is what? This one is A, right? So I'm writing this one here and
So
this one
that's
here.
all I understood.
A plus,
From the question, I have a doubt, sir. So it's
okay, tell
given.
me.
Could you just show the question once? So it's
Yeah,
when
this is
student
the
will
question.
pass, he passes in either section 1 and 2 or section 1 and 3. So this is what
Yeah,
you have converted into the. Okay, so now
yeah,
the previous
in
question, could
mathematical
you just say
expression.
how it will be when the events are
Sorry.
dependent? That is not independent. For the previous question, could you just say how will we do if the events are not dependent?
That one will take. There will take.
Not
So
independent.
did you get this question? Did you get this
Sir,
question?
no, sir.
Yeah. Sorry.
Sir, if
Yeah.
we talk about balls, that one red ball or one blue ball, then we
One
don't use
red
this
ball,
A intersection B.
one red ball or one blue ball.
Yes, sir.
Sir, I have
So
one doubt.
what is that? Okay.
Sir, suppose there is a bag and there are 5 red balls and 5 blue balls,
Okay.
and we select one ball randomly. Then what is the chance that it is a red or a blue ball? So, sir, in that we don't use P A intersection B.
You're not audible.
Hello, sir.
Sir,
Abhilash is facing some technical issues. He'll join in 2 more.
Sir, one question I have, can I ask?
Yeah.
What is the way you think and write those
Yeah,
events?
tell
I
me.
mean, is there a way? We can follow those, tricks to enlist all the events in the probability, because the trick is only the writing the events. So the thing is, every time I think of events, I fail writing the right events over there. That's a problem. I mean, I'm not able to figure out what is the right event to write. How do you think on
So
those?
Yeah, first you read the question, right? And whatever it is asking, and through whatever it is asking, through that you have to relate from the information that is given in the question. So see, the thing is, here are many questions in the solve with us. So try to observe how we are doing the events, how we are writing, right? And also see, in probability, what happens is writing the events helps you, because from that expression you have to convert it into the mathematical expression, right? So that you can solve the question. So the ultimate game is converting the language to the mathematical expression actually. Okay, so there's a problem with this. Wait, everyone, right? Okay, so let's take another question. I think in that question it will help you a lot. Okay.
Sir,
So wait. Yeah.
in the previous question, you have mentioned that A probability of A union B is 1/3. How come, sir? You have admitted 1/3.
It is given in the see, probability of passing the aptitude test is given to you 1/3.
Oh.
So the probability that he passes is given to you 1/3. So that's why I'm equating it with 1/3. Okay. Okay, let's go to the next question. So just give me 1 minute. This is the steps. Try this question.
Good evening, everyone. I'll be continuing the rest of the session. So, shall we start with solving this question?
Yes, ma'am. Yes, ma'am.
Yeah. So, yeah. So we know that M1, M2, and M3 make 25%, 55%, and 20% of the scores respectively. And we know that M1 has 1% defective, M2 has 3%, and M3 has 2% defective. So if a score is chosen at random, we have to find the probability that it is defective. So what did you all get as the answer? Did anyone answer this question? Okay, so how I solve this is we'll have the probability of it being defective. It can either be defective, it can be from M1 and defective.
Ma'am,
Yes.
ma'am, the answer is 0.023.
1 second.
0.023.
Yeah, 0.02. That is the answer. Yeah, so probability of it being defective, it will either be M1 and defective, or it can be M2 and defective, or it can be M3 and defective. So probability M1 and of M1 and D is basically saying M1 intersection D, right? And this is M2 intersection D plus M3 intersection D. Now we'll use the formula probability of A given B is equal to probability of A intersection B by probability of B. So if we're using this, we can say that probability of A intersection B is equal to probability of A given B multiplied by P of B. So we'll use that everywhere here. So P of T will be equal to P of M1 given 1 second. Yeah, probability of defective given M1 into probability of M1. So we know so this sentence, when we're saying it's known that some past experience are 1%, 3%, and 2% are defective by M1, M2, and M3, we're saying probability of defective given that it's M1 is 1%. Probability of B given M2 is 0.03. Similarly, probability of D given M3 is 0.02. So this is something we know. So, and probability of M1 is also something we know. So we will just use this part. Yeah, so probability of D given M1 is 0.01. Probability of M1 is 0.25 plus probability of D given M2 is 0.03 and probability of M2 is 0.55 plus 0.02 into 0.2. And if we just simplify all of this, we'll get 0.02. So yes, the answer. Any doubts in this question? Is it clear?
No.
This is a simple and straightforward question. So we'll move on to question prelude 2 of question 4. So in a population, 45% are female and 55% are male. Among all the females, 9% are left-handed, and among all the male, 11% are left-handed. A person is randomly chosen from the population. So if the person is left-handed, what is the conditional probability that the person is male? I'll give you 2 minutes to do this question and then we'll discuss. So shall we start solving this question? Has everyone completed this? If you want more time, I can give you some more time as well. Okay, so we'll discuss. So what exactly are we supposed to find in this question? So they're asking us if the person is left-handed, what is the probability that the person is male? So probability of the person being male given the person is left-handed. So, and what do we know here? We know that probability of the person being female is 0.45. Probability of male is 0.55. Probability of left-handed given female is 0.09. And probability of left-handed given male is 0.1. So all of these things are things we know. And using the base rule, we know that probability of M given L is equal to probability of L given N into probability of N divided by probability of L given M into P of M plus probability of L given F into T of M. So it's just a straight substitution here. Probability of L given M is 0.11. Probability of M is 0.55. And then 0.11 into 0.55 plus probability of L given F is 0.09. Probability of F is 0.45. So if we solve this, we'll get
Can we use here conditional probability?
yeah, we did use conditional probability here, right? L given M, these are conditional probability. Yeah. Yeah, so the answer for this question will be 0.599. So I can just say 0.6. Is this what everyone got? Okay, Arnav, I see you got 0.55 and Rakesh 0.06. Yeah, so is this clear how we got this?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Now, could you just show the question, please?
Yeah, this is the question.
No, ma'am, could you just show the question, please?
Yeah, can you take a screenshot then?
Yes, ma'am. I mean, how do we know whether we have to use base rule or conditional probability? Because base rule has on the
You can use both. Like if you're using conditional probability, you would be saying probability of M intersection L divided by probability of L, right? So how do you find probability of M intersection L?
No, ma'am, I know the how to do mathematically, ma'am, but when the question is given, how do we find out? Because in both of them, one thing is given and we're asked to find.
We are given all of these. So, and if we're using the other, you can use the other method also. But when you write this down, you can see probability of M intersection L. And we don't
Yes,
have
ma'am, I
any
got
of that. Yeah, so then you'll know you have to go to this. Just look at what is given to us. And first you have to write down what is given to you. And then you'll know which formula to use. Here we're given conditional probability, so we use base formula. If we were given intersection, if we were given all of this, we would try to use this. Yeah.
The
So-
denominator part is not exactly equivalent to the base formula, right? I mean, the base formula says, for an example, it says P F given E is equal to P of E given F into P of F divided by P of F into P of E given F plus P of F complement
Yeah.
into P of
So-
E F complement. But
Yeah,
here
so
the
we know
L of
that-
L and F, right? The second part of the denominator that I'm not able to.
Yeah, so so in this data set, you can see that M and F are disjoint, right?
Yeah. We are not able to hear you. We lost you.
Yeah, sorry. Yeah, so
Okay.
yeah, I was saying, so either a person is male here or a person is female. These two are disjoint, and there are no other steps. So either this will happen or this will happen. So that's another way of saying M complement is equal to F. M complement basically means everything that is not M, right? So everyone who is not male is female. So M complement is equal to F.
Okay.
So here you can say M complement is that.
Sure.
Yeah. Okay, so now we'll move on to question 4. So in the manufacturing firm, so this is the same description as prelude 1 to question 4. So here the question is, if a screw is chosen at random and found to be defective, find the probability that it is made by machine 1. So shall we discuss this question now? So this question is similar to this question is similar to prelude to a question 4. So again, let's write down what is given to us. So if anyone can say this, Anya can say this, you can do that. So probability of M1 is 0.25. Probability of M2 is 0.55. And probability of M3 is 0.2. And then we know that probability of the screw being defective given M1 is 1%. Probability of it being defective given M2 is 0.03. And probability of it being defective given M3 is 0.02. And they're asking us if a screw is chosen at random and found to be defective. So we know that it's defective. We need to find the probability that it is manufactured by manufacturing firm N1. So again, when we look at the given and what we need to find, we can figure out that we need to use the base formula. So here, M1 given B. So the numerator will be the probability of M1, probability of B given M1 into probability of M1 divided by probability of B given N1 into probability of N1 plus, so now here we have to So here we can have B and M1 or B and M2 or B and M3, right? And we know that M1, M2, and M3 are distinct and disjoint. And we know that together they make up the whole thing. So here we can say probability of B given M2 into probability of M2 plus probability of B given M3 into probability of M. And now I can just give the formula. Sorry, replace everything here. But in prelude 1, we found out probability of B. So probability of B, this denominator here is basically probability of B. We use the same formula here. If you look at this formula and if you look at this formula, it's the same. So since we already found out P of D to be 0.023, we don't need to find the denominator. We'll just substitute it. So probability of B given M0 with the denominator 0.02. Yeah. And now probability of B given M1 is 0.01. And probability of M1 is 0.2. If you simplify this, you will get 0.109. Yeah, Nandakumar, you're correct. I mean, if you're doing it with 2 digits, then it's fine. Yeah. Yeah. So I can see a few of you did get it wrong, but a lot of you got it correct. So any doubts in this question?
No, ma'am.
So
Ma'am,
now, yeah.
ma'am, like, shall we see some tricky question instead of direct questions? If it is possible.
Yeah, we could do that in the next session. I think these were prepared by the instructors. I think these are previous year of this question. So, okay. So in the next session, we can try to get more tricky questions. Yeah, so for now, let's do this question. You can take 3-4 minutes to read the question and we'll discuss the answer. This one is a simple question, so yeah, Derek.
Can you, ma'am, speak louder?
Yeah, is this any better? Hello.
Hello, ma'am.
Yeah, sure. Should we discuss this question now?
Ma'am, I have a little doubt because I'm lagging much in this stats. So, can you tell me that P A by B is from which week?
A by PB.
Yeah, when the conditional probability like we discuss. Yeah, like D over M3, something was that.
Yeah, I think that's week 8 of that.
It's week 8, ma'am?
Yeah.
Okay, thank you.
Yeah, so we'll discuss this question now. So A is the event that the sum is 6, B is the event that the sum is 7, and C is the event that the sum is even. So if so we'll just look at the solution here. A can be done in these many ways, B can be done in these many ways, and C is all of these. So are A and B mutually exclusive?
Ma'am, can you please zoom the question?
Yeah. So this is the question, and this is the solution. So are A and B mutually exclusive? So when we're talking about two sets being mutually exclusive, we're asking if there's any intersection here.
Excuse me, ma'am.
Yeah. Yes or no?
Ma'am, so the correct options are A and C, right?
Yeah.
Okay.
So A is wrong because A and B, sorry, A is correct because there is no intersection. So A and B are mutually exclusive. Now A and C, so here A is the event that the sum is 6. And since C is the event that it's even, 6 is an even number. So all the outcomes in A will also be in C. So these are not mutually exclusive. So now option C is event A and B are independent. Yeah, so if we have to see if A and B are independent. So since A and B are independent, P of A intersection B will be so to check if two events are independent, we have P of this it should be this condition should be satisfied, right? So P of A and P of B will be two constants, C1 and C2, and they won't be equal to 0. But P of A intersection B will be 0. So this can never be true. So they cannot be independent. Okay, so C is wrong, everyone. Just because they're mutually exclusive does not mean they're independent. Is option C clear to everyone? Are there any doubts for option C?
No, ma'am.
Okay, so option D is they're asking us if A and C are independent. So here P of A intersection C should be equal to P of A into P of C. Now we know that A is fully contained in C, so probability of A and C happening is the same as probability of A. So for this to be true, we need P of C to be 1, but that's not true. So this won't be equal. So again, it's not independent. So only option A is correct in question 5. So now look at question 6. An urn contains a total of 10 balls, out of which 3 are black and the remaining are red. Suppose a sample of 4 balls is drawn from the urn, one by one, with replacement. So yeah, don't forget the with replacement part. What is the conditional probability that the first, third, and fourth ball will be red, given that exactly 3 balls out of the 4 in the sample are red? You can take a while to solve this question and then we'll discuss.
Hello, ma'am. Hello, ma'am.
Yes, Navya.
Can you please show me the answer to the question number 3?
Question number 3. Yeah, so this is the first part of it.
Yes, ma'am.
And this is the second part.
Yes, then the final answer is, ma'am, and this is
Final answer is 2 by 3. This is it. Yeah. Yeah, so now you can solve this question. Yeah. Has anyone solved this question?
I mean, the previous question, I just have one doubt.
Yeah, fine. We'll discuss it after the question is over.
Okay.
Okay, but what exactly is your doubt?
No, I'm fully just show that question because I was not able to listen to it. So.
Okay. Then I'll show
Or
it
maybe
after.
I'll ask after this question gets over or at the end.
I'll show it after this question. Okay, so let's discuss this question now. So let's first write down everything that is given to us. Is there a lot of background noise from my side? Can anyone tell me if there is?
No, ma'am, there is no background sound.
Okay, so we have to find out the probability that the first, third, and the fourth ball will be run. So let's consider this as event A, and we'll take event B as exactly 3 out of 4 are run. So what we need to find is probability of A, and it is given to us that B has happened. So just using the conditional probability formula, we can say that we have to find probability of A intersection B by probability of B. Before that, let's just write down everything given for us. We know that 3 are black and remaining 7 are red. So, and we know that a sample is chosen with replacement. So the probability of getting a black ball in any of the terms is 0.3. And the probability of getting red in any one of the terms is 0.7. And since it's done with replacement, we will have the same probability for every term. Yeah. So now probability of A intersection B means we need the first, third, and fourth ball to be red, and we need exactly and we need exactly 3 of the 4 balls to be red. So these 3 balls are red. So that means basically we need we need the condition to be red, black, red, red. So the first, third, and the fourth ball are red, and the second one is not. So this is the only one condition in which this can happen. So probability of A intersection B will be so probability of getting this red will be 0.7. And probability of getting this black will be 0.3. Again, red will be 0.7 into 0.7. And so this will be the final probability. So we'll just leave it as is for now. Now we'll calculate the probability of B, which is exactly 3 out of the 4 balls are red. So if we have 4 balls, we need 3 of them to be red and 1 of them to be black. So if 3 of them are red, we will have the probability of 0.7 into 0.7 into 0.7. And the one ball which is black will have 0.3. And we have to select 4 from the 3, which will be red. So you'll have to multiply this with 4C3. So the final answer will be 0.7 into 0.3 into 0.7 into 0.7 divided by 4C3 into 0.7 the whole cube by 0.3. So now we can simplify this like this. So it will finally just be 1 by 4C3. 4C3 is 4 factorial by 3 factorial into 4 minus 1 factorial. So this will be 1 by 4, 3 factorial, and the 3 factorial from here can be cancelled out. And 4 minus 1 is 4 minus 3. 4 minus 3 is 1. So the answer will be 1 by 4. Is this what everyone got?
Excuse me, ma'am.
Yeah.
Ma'am, I did not understand the probability of B. How did we calculate the
Yeah.
probability of B?
Okay, so we have 4 balls. B1, B2, B3, and B4. This is our sample selected. So we have to find the number of, we can do this in a different way then, instead of doing it like this. So we'll find it as the favorable outcomes by the total outcomes. So how many total outcomes do we have? Since it's
10.
with replace, yeah, so one ball it's 10. We have 4 such balls, so it will be 10 into 10 into 10 into 10.
Yes, ma'am.
Yeah. So now we need favorable outcomes. So the favorable outcomes would be all conditions in which you have red, 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 and brown. So it can happen in this way. It can happen in this way. It can happen in many ways, right? So then how do you
Yes,
find the
ma'am.
number of ways in which this is done?
4C3.
3. 4C3. That's why the 4C3 comes. And then the number of ways. So we will have a combination, a set of positions like this. So now we need to find which red ball this will be. So there are 7 red balls to choose from. So which red ball will this be? There are 7 ways of choosing this red ball. Similarly, there are 7 ways of choosing this red ball also, because we replace whichever ball we took here. And then again, this has 7 ways. And here, since it's a black ball, we only have 3 balls. So we have 3 choices. So this will be the final one. For just
Okay,
for
ma'am.
P of 3. Yeah. So
Okay, ma'am.
and
Got it,
if you
ma'am.
look at this, and if you look at this, we have this 7 by 10, they've taken it as 0.7. The 7 by 10, 0.7. Yeah, that's why I right click.
Okay, ma'am. Got it. Thank you, ma'am.
So any other doubts in this question? Yeah, so that's the end of the solve the first session. If there are any doubts with respect to these 6 questions, you can ask it now.
Hello, ma'am.
Yeah, yeah.
The question, where M1, M2, M3 were there, no? Can you show me the first part of that solution where the solution was 0.023?
Yeah. Yeah, so this is the first part.
Okay, ma'am.
This is the second.
Wait, ma'am. I need the first part, ma'am.
Yeah.
Okay, then ma'am, calculation of this is?
There are 3 parts to it. This is the second part.
Okay.
And this is the third part.
Okay.
Yeah.
Okay, ma'am. Thank you.
Yeah. And Danya, you wanted the 5th question. So this is the 5th question.
Yes, ma'am. Actually, could you also explain the question, ma'am? Because it was not there at the time.
I did not explain. Are you asking for the solution or an explanation of the question itself?
Not the question, ma'am, the solution.
Okay. So did you read the question?
So question I got, ma'am.
Okay. So the first option, events A and B are mutually exclusive. So if you look at this, you can see A and B don't have anything in common. So as the intersection is empty, it's mutually exclusive. That's what mutually exclusive means, right? It means they're disjoint.
Yes, ma'am. Mutually exclusive is same as disjoint.
Yeah, zero disjoint. So if you look at A and C, there are many in common. 1, 5 is here, 2, 4 is also here. All of these will be here because A is the event that the sum is 6 and C is the event that it's even. And since 6 is even, all the outcomes in A will be in C. So they are not mutually exclusive. A will be completely contained in C. So B is wrong. Now, if they're asking for events, A and B are independent. So one thing we do to check independence is A intersection B should be equal to P of A into P of B. Now, the intersection it will be in the null set, right? So this will be 0 because the sum can't be 6 and 7 at the same time. But if you look at the right-hand side, this will be some constant C1 into some constant C2. So this won't be equal. Probability of A and probability of B are non-zero numbers. Since this is not equal, it's not independent. So C is wrong. Is it clear?
Yes, ma'am. The D option.
Yeah, D option will also follow the same thing. So we have to check probability of A intersection C is equal to probability of A into probability of C. Now, one thing we realized earlier is A is completely contained in C, right?
Yes, ma'am.
Yeah, so probability of A intersection C is basically the probability of A happening. Because if this is C then and this is A, then the intersection is A itself. Now, can this be true? P of A equal to P of A into P of C. Yeah. This will only be true when P of C is equal to 1. And we know that's not true. So this won't be true. So because it's not true, A and C are also not independent.
Ma'am, and also while finding probability of A intersection C, what will be the denominator or probability of A, probability of C, whatever?
There is no denominator. This is just a condition that we use to check it.
No, denominator means for the probability, like some X by the total outcomes rate.
We don't have to look at that. Yeah, we just have to find. Yeah. So okay. So you're asking like to find probability of A. So so we're rolling a pair of fair dice. So the first dice will have 6 outcomes from 1 to 6.
It will be by 36.
Yeah, it will be by 36. And the numerator will be yeah. Since there are it will be since there are 5 here, it will be 5 in the numerator. But to check independency, we don't need to find out what the exact value is because we know that it's 0 in the first case.
I mean, in all these exams, which score will be considered as a good score? There'll be some range, right?
Are you asking about which scores will be getting a grade as, which scores will be getting A, like that?
No, ma'am. Which mark or which percentage can be considered as a good? Not good means not literally that one.
Yeah. It depends on the quiz. Some quizzes will be, if they're hard, it depends on you. Yeah. If just try to do better than quiz. So any doubts on these set questions? Yeah, so if there are no questions, we'll end the session now. Thank you for joining. Yeah.
Solvitors of week 7.
Sorry?
Solvitors of week 7, can you share it?
I think the video is on YouTube. So maybe you can look at that. I don't think I can share the PPT. Okay. Yeah, thank you. You can leave the session now.